Hello students, welcome back to IIT Foundation classes and 8th class, right? So we started the first chapter, that is solutions, okay? And in the previous class, what we discussed? We have discussed about the matter and its classification, okay? Chalo, so once again, welcome back to IIT Foundation classes. I am your chemistry faculty, S. Mohan. Right, students? So in the last class, we discussed that matter, anything which has a mass and occupies the space is called as a matter, and it can be divided, means classified in two ways. One is based on the physical states, right, like solids, liquids and gases, and second one based on the composition, chemical composition, right? And the chemical composition, they are classified into pure and impure, or we can say that mixtures, right? So pure means what? Which are made up of one kind of substances are called pure substances. Examples, elements and compounds. And mixtures are what? The compounds which are the substances which are made up of two or more different types of substances are called, okay, mixtures. And again, mixtures are classified into two types called homogeneous and heterogeneous. Again, heterogeneous is classified into two types called colloids and suspensions, right? So this we done, and next we also discuss like what are pure and mixtures, right? Once go through this slide, okay, and then we see the homogeneous mixture, heterogeneous mixture. This also we discussed, homogeneous and heterogeneous. So classification of the solutions also we discussed. And true solutions, yes, true solutions also we discuss. No students, true solutions means what? A homogeneous mixture of two or more components is called as a true solution. And example what I give, salt solution, like salt in water, right? So salt in water is called as a true solution, okay, and sugar dissolves in water also comes under the true solution, okay. So this example I have given to you. This is a glass tumbler, and in which we have taken the water, and this we are adding the salt. When we are adding the salt or sugar, you can see the crystals, but on stirring it, it dissolves, disappears, okay, and thoroughly mixed with the water, and that makes the true solution, okay. And characteristics also we studied about the true solutions, right? So what are the characteristics? Particle size is up to nanometer. Did you remember what is nanometer? 10 to the power of minus 9 meter is called as a nanometer, and they are transparent, they cannot be separated, means they cannot be filtered, and they are very stable, right? This we discussed. Okay students, now today's our topic is colloidal solutions or colloids, okay. Colloid is what? It's a heterogeneous solution. What is heterogeneous? Yes, homogeneous and heterogeneous, right? So heterogeneous, again they classify into two types I said. One are called colloid and second called suspensions, okay. So colloidal solutions are the solutions in which the dissolved particle size is greater than nanometer, or we can say the size of the particles is 1 to 1000 nanometers, 1 to 1000 nanometers, okay. So here you see colloidal solutions or colloids or heterogeneous. See students, here this is very important point. What you need to remember is they are heterogeneous solutions. These are what? Heterogeneous mixtures, and the solute particles that are intermediate in size. Intermediate means what? Not so smaller as like in the true solutions, are not bigger than the suspensions. They are intermediate, means what? In the middle, okay, the size of the particles are middle of the true solutions and suspensions, right? And between those true solutions and suspensions, okay. And examples for colloid solutions are milk, blood, ink, fog. This all we can give the example for the colloid solutions, okay. Now here just I told you that particle size, okay, they ranges from 1 to 1000 nanometers, 1 to 1000 nanometers, right? And appearance, colloid solutions appear translucent. What are the translucent? You know that substance are three types, right? Transparent, translucent and opaque. Transparent means what? Through which light can pass, are called transparent. What are translucent? through which light can pass, but partially, not completely. Okay, and opaque means what? Which do not allow the light to pass through them. Okay, so opaque, but here mostly they are transparent or translucent. So this here they appear to be translucent or milky, or what? Milky, due to the scattering of light by the particles. So here they are translucent, not perfectly transparent, or they are not perfectly opaque. Means what? They do not allow the light completely through them, or they do not stop the completely light, but they partially allow the light to pass through them, right? Such solutions is called a translucent solution. So colloidal solution is a translucent. Okay, and separation. Now here they also cannot be separated by ordinary filtration. So you can see here colloidal particles cannot, can you see here? Cannot be separated by normal filtration. Okay, by normal filtration we cannot separate them. In the last class also we discussed, like, salt water. If you add the salt in the water, after dissolving, can you separate the salt from the salt water by filtration? No. So here also the same, right? Now stability. Colloidal solutions are relatively stable. Relatively stable means what? They are stable, but they are not so stable like true solutions, or not unstable like suspensions. Okay, so these are the colloidal solutions. I understood the colloidal solutions. So colloidal solutions means what? A solution in which the dissolved particle size ranges from 1 nanometer to 1000 nanometer. Means what? A little bigger, okay, so than the true solutions. Okay, so that is about the such type of solutions are called colloidal solutions. Okay, students. So once you pause the video and just you can see for 2 minutes. Shall I go for next slide? So here you can see this is a milk. Okay, what is this? This is a milk. Milk is an example for the colloidal solution. And what is this? This is a ink. Okay, so ink is also an example for the colloidal solution. So these are the colloidal solutions. Clear? Okay, so we completed the second type. So two types are completed. One is true solutions, second one are colloidal solutions. Okay, now let us see the third one, suspensions. What is the third one? Suspensions. So suspensions, if you know the true solutions and the colloidal solution properties, then you can able to say what are suspensions, right? So here suspensions are also a heterogeneous solutions. What are they? Heterogeneous solutions in which particles, dissolved particle size are bigger. Okay, means what? They are greater than 1000 nanometer. They are greater than 1000 nanometer. Means what? Dissolved particle size is bigger than the even colloidal solutions. So they are bigger particles. Okay, such solutions are called suspensions. Clear? So see the suspensions. Suspensions are the heterogeneous solutions or heterogeneous mixtures with the solute particles are larger. Can you see the larger and also readily settle down? Okay, if you left undisturbed. Okay, for example, what you do is you take one beaker. Okay, you take one beaker. If you don't have a beaker, you can take one glass tumbler at your home. Okay, take one glass tumbler, right? In that, take some water. Okay, so here we can give orange pulp also example for the suspensions. Okay, so now here what I do is, here I'll draw the diagram. Okay, so here can you able to see? So this is let a beaker or glass tumbler. Now in this what we are doing? We are taking the water, right? Now in this water, what we do is we add chalk powder. What we are adding? Chalk powder. Okay, so chalk powder. You know the chalk powder, right? So in your school there will be a chalk piece. Teachers write on the board with chalk piece, no? So chalk powder. Okay, make a chalk into the powder and add that powder here. Okay, and stir it now. Okay, on stirring, what you'll observe, it looks like the chalk powder is dissolving in this water. Right now, after stirring, you feel that. Okay, by seeing, you feel that chalk powder is dissolved. Okay, and you also see the change in the color of the water. Water color changes to white in color. Right, so you feel that that chalk powder is completely dissolved in that water. Okay, then what you do, take this glass tumbler and place aside for half an hour undisturbed. Without disturbing it, keep aside for half an hour, 30 minutes, right? And after 30 minutes, if you see, what you'll observe, come on, see, what you'll observe? Very good. So you observe that all the chalk particles are getting settled down. Yes, all the chalk particles will come down and settled at the bottom, and see the water will be comes to the upper layer. Again, now water becomes transparent. Water becomes transparent, right? So this type of solutions are called suspensions. What they are called? Suspensions. So when you add this chalk powder, then after stirring, so here if you keep aside, all the chalk particles will comes down and settle, means water, they are not mixing with the water. Yes, so such a type of solutions are called suspensions. Okay, so readily settle out when left undisturbed. If you without disturbing, if you keep aside, then what happens? They get settle down at the bottom. Okay, now examples, muddy water. Yes, this also you can do. You can take. So take one tumbler and then add some mud and stir and keep aside. So what you'll observe? So that all mud will be settled down. Okay, and here orange juice with pulp. Yeah, you know that pulp. Okay, like orange juice, all like pulp will be settled at the bottom, and even paint also. You can give an example. Okay, so these are the suspension, students. So here you can see here this is a picture for suspension. We can give an example for suspension. Yeah, what you are observing? So here this is a liquid, okay, liquid, and here the solid particles were added and mixed with it, and I'm keeping for some time without disturbing. So you can see here, you can see here. So this part you can see here, all solid particles are settled at the bottom, right? So this is an example for the suspension. Clear suspension? Any doubt? Right? What are the characteristics of suspension? So just I told you that what if you know the characteristics of true solutions and colloidal solutions, then you can write the properties of the suspensions. So here the first property about the size of the particles. Size of the dissolved particles are greater or bigger than 1000 nanometers. Bigger than 1000 nanometers. So see suspension particles are typically larger than 1000 nanometers. Okay, they are larger than 1000 nanometers, means particle size will be bigger, and you can see with a naked eye also. You can see with a naked eye. Where you see the salt after dissolving the salt in the water, in the salt water? Can you see the particles with your naked eye? No, because their particle size is very, very small in terms of nanometers. But here you can see the chalk powder. Yes or no? You can see the chalk powder in the beaker. So the meaning is what? Here the size of the particles are larger. Okay. Now how they appear? Just want to tell you that they are opaque. Okay. So when you see all the chalk powder is settled down, all the chalk powder is settled down. So now when the chalk powder is settled down, if you pass the light through that settled part, does this light passes through that one? No. These particles, as they are bigger and they are settled down, they do not allow the light particle to pass through them. So that property is called opaque. Okay, what that property is called? Opaque. So here suspensions are opaque. Why they are opaque? Because they block the light due to their bigger size. Why they are opaque? Because they are not allowing the light to pass through them. Why? Because these are bigger in size, so they do not allow the light to pass through them. Hence, they acts like a opaque. Okay. And next, this also said that suspended particles can be separated by filtration. Student, this is very important point here. So chalk powder you mixed with the water, and then you kept aside, and then it gets settled down. Now, if you want to separate the water and chalk powder, can you separate them? Yes, by filtration. You just take one like cloth-like substance and filter it. Then you'll observe that all water will be passes through that cloth or filter paper, and all the chalk powder we can collect over it, right? So we are separating the water and the chalk powder. So here in the suspensions, the particles, the dissolved particles can easily separated by the filtration. And last one, stability. No, they are unstable. Why they are unstable? Unstable means what? Stable means what? Already I said that if once we dissolve the particles in that, if they are in dissolved state only. Okay, if you take the water and salt, water on stirring, salt on stirring, the salt completely dissolves in the water and it disappears. And how long you keep for a long, okay, then you cannot see the salt particle that they are going to settle down. Yes or no? So the meaning is what? Those such solutions are called stable. But here what's happening? All the chalk particles are coming down and settling. So here such solutions are not stable, but they are called unstable solutions. What are they? Unstable solutions. So students, these are the properties of characteristics of suspensions. Okay, so take 1 minute time to read it, all the 4 properties, and then we go to the next slide. Okay students, so complete characteristics of suspensions, right? Now we compare all these 3 solutions properties. Okay, so now you see we are going to compare the characteristics of all the solutions in one table. Okay, so 3 solutions are what? True solution, colloidal solutions, and suspensions. Okay, now particle size. First we come to the particle size. We are comparing now. The particle size in the true solutions is less than nanometer. Okay, means less than 10 to the power of minus 9 meters, less than nanometer. Can you see the symbol? So less than 1 nanometer. NM stands for nanometer. Colloidal solutions of water, their size ranges from 1 to 1000 nanometers. Okay, so here 1 nanometer to 1000 nanometers. Okay, now third one is water suspensions. Suspensions are larger. Okay, the particle size of the suspensions is larger than the colloidal solution. Means what? Greater than the 1000 nanometer. Can you see here? Greater. Can you see this symbol? Okay, greater than the 1000 nanometer. Clear? Now, let's see the second property. Second property is what? Appearance. What is the second property? Appearance. Okay, how they appear. So when you take the salt solution, then how it appears? It appears transparent. Transparent means what? Through which light can pass, right? So generally, true solutions appear transparent. Okay, and what about the colloidal solutions? Colloidal solutions appear translucent. Means partially light can pass. And suspensions opaque, right? So see now, appearance true solutions are transparent, right? Colloidal solutions translucent or milky, also you can say. Suspensions opaque. Clear? Chalo. Now third property is water separation. Can we separate the salt and water from the true solution? No, right? So the true solutions, the particles cannot be dissolved, particles cannot be separated from the solution. By ordinary filtration, yes, separated means what? We can separate, but we followed a different processes. No? For example, if you want to separate the salt and water, what do you do? Yes? Yes, we boil the water. On boiling water happens, water get evaporated, only salt will be left. So we can separate the water and the salt, but not by filtration process, not by filtration process. So here we are discussing about the separation of particles by filtration. Okay, so true solutions cannot, means the components of true solutions cannot be separated by filtration. So cannot be filtered or cannot be settled also. Those particles cannot settle at the bottom. Okay. Now, whatever the colloidal solutions, colloid also same, they also cannot be separated. They also cannot be separated, but sometimes they may settle. May means what? Not in all conditions. Okay, they may settle. And what are the last one? Suspensions. Suspensions can be separated. Example, chalk powder I said. Okay, can be separated. Okay. Then come to the stability. They are stable here. Stability means what? The dissolved particles should not come out and they should not settled. So that is called stability. So here the solutions of true solutions are stable. In that, what are the dissolved particles are there? They cannot be comes down and they cannot come out of the solution and they cannot be settled. Okay, so they are mixed always with the solution. So the meaning is what? Such solutions are stable. And next one is what? Colloidal also of course stable. Okay, they are relatively stable. Means relatively stable means what? They are not so stable as the true solutions, but not they are unstable like suspensions. They are stable. Okay. And last and final one is what? Suspension. Suspensions are unstable. To be stable, always we need to stir it continuously. So requires stirring continuously. It requires to stir it. If you stop stirring and if you keep for some time undisturbed, then all the particles get settled down. So this is unstable. Clear? So this is a comparison of the characteristics of true solution, colloidal solutions and suspensions, right? So let's go through this one slide. Okay, finished? Chalo. Till now what we completed, that summary in short. Now I am not going to explain you. Okay, so now what you do is you stop it and from yourself you try to revise it and then check on the board. Otherwise, any one of the students come and try to explain what you have studied till now to others. Chalo, let's go through this one, read. Finished? Okay, once again here. So true solution, colloidal solutions and suspensions of the different types of solutions based on the size and stability of the solid particles. So here based on the particle, dissolved particles, they are called as solid particles based on the size and stability. Here the solutions are classified into three types. They are called true solutions, colloidal solutions and suspensions. True solutions are the molecular sized particles and they are transparent. True solutions are what? Molecular. Molecular means what? Very, very small and they are stable and transparent of course. Colloidal particles or particle size are little bigger, okay, relatively means they are intermediate size and they are translucent or milky. Suspensions, larger particles and opaque. That's all students. So very simple. So with this topic is done. Okay. Now in this out of these three types of solutions students, here we are going to discuss first about the colloidal solutions once again in detail, and after the colloidal solutions again we are going to discuss about the true solutions, and on the true solutions, based on the true solutions we are going to solve some numericals here. Numericals are there in this topic. Even though it is a chemistry, you will have the numericals. Yes, you see the numericals only in the physics. Okay, but in the chemistry also you will have a numericals. So here in this chapter we have the numericals, that is depending on the concentration topic. Okay, so we discuss that. So first now once again in detail we go to the colloidal solutions. Till here it's fine. Chalo students, now it's a very, very important topic. You need to understand the colloidal topic very clearly. Okay, so colloidal solutions. What are the colloidal solutions? The intermediate, middle type of solutions are called colloidal solutions. right? So in the colloidal solutions, it consists of two components. You know that any solution is made up of two components are required. So in the two components, in that one will be relatively large in quantity, one will be relatively less in quantity. Yes or no? So here the relatively large in quantity is called dispersion medium. What is called dispersion medium, and which is less in quantity, that is called as a dispersed phase. What is called dispersed phase. Okay. Now, for example, you see here, students. For example, I will take which solution we take. Okay, here liquid with solid. So, for example, let us take this gel we take. Okay, example for gel is what? Jelly, cheese, and butter. Okay, so here you can see cheese. Okay, so here example for the colloidal solution is cheese. Okay, so what is cheese? You know the cheese. Okay, generally we purchase from the bakeries and apply the cheese on the bread and we eat, right? So that cheese. How this cheese is made up of? It consists of two components, students. One is called water, second is called fat. How the cheese is made up of? Water and fat. Water and fat. So these two combines to form the cheese. Okay. So here you can see. Yeah. So you see liquid and solid. So that is called gel and jelly, cheese or butter. Okay. So here, so here the cheese is made up of fat and water. So you can see fats. Right. So fat suspended or dispersed in water. So here two components are there, right? One is fat suspended and second is water. Fats and second one is water. Okay. Similarly, if you take the soda water also, soda water is generally consists of water and gas. What it consists of? Water and gas. Chalo, I'll take for example like soda water is because this is everyone will have a soda water, right? So soda means water, soda water and carbon dioxide. Did you see any time like some roadside also they can see they can make a soda, so how they make? They take the water in a bottle and there will be one small cylinder will be there in which the carbon dioxide gases will be there, and they press, so what happens, the carbon dioxide gas will be going into the water and that makes the soda, right? So here in this one if you see in the soda, so water and carbon dioxide means water, I can write like this, carbon dioxide, formula is what? CO2, carbon dioxide in water, carbon dioxide in water. The meaning is what here? Carbon dioxide is lesser in quantity, means water in little quantity is there, and water is larger in quantity, means what? More quantity. More quantity of water will be there, and in that some carbon dioxide gas is there. So amount of gas is very less, but water is more, right? So here which is more in quantity, that is called dispersion medium. What is called a dispersion medium, and which is less in quantity, that is called dispersed phase. What is called dispersed phase? For example, here carbon dioxide in water. So carbon dioxide is in lesser quantity, so this is called dispersed phase, and which is in larger quantity, that is called a dispersion medium. Clear? Chalo. Now that how can we define? So see now, dispersed phase is one of the two phases of colloid, means colloid consists of two phases, means two components. So here we are calling two components as a two phases. Okay, two phases. The dispersed phase, okay, and the dispersion medium, two are there. Dispersed phase. So this is a dispersed phase, dP, and this is a dispersion medium, that is dm. So which is larger, that is dm, which is lesser, that is dp. Okay, so dispersed phase is a discontinuous phase that is distributed throughout the dispersion medium. So if you pass the carbon dioxide is dispersed throughout the water. So hence the carbon dioxide is called as a dispersed phase. Now, what is the dispersion medium? The medium in which the colloidal particles are dispersed. The medium, okay, so which is more in quantity, in which the colloidal particles are mixed or dispersed. So that is called a dispersion medium. For example, take carbon dioxide in water. So water is called dispersion medium, and carbon dioxide is called a dispersed phase. Clear? So this is the definition. Did you understand the dispersed phase and dispersion medium? So if you take the solution, colloidal solution consists of two components. In the two components, one will be generally more in quantity, other one will be generally lesser in quantity. Which is lesser in quantity, that is called phase, dispersed phase. And is larger in quantity, that's called a dispersion medium. Clear? Chalo. The same definition, your material, how it is written, see around. Dispersed phase and dispersion medium. It is a component. Okay, it is a component. See here, it is a component with a smaller portion here to remember. This is a very important point. Smaller portion, which is called phase, dispersed phase, which is present in smaller portion, that is called dispersed phase. Now, dispersed medium is what? It is generally component present in excess. This is important part here. Excess means what? More, which is present in more quantity in a colloidal solution. That is called a dispersion medium. Okay, which is lesser in quantity. That's called a dispersed phase. Now here one colloidal solution is made up of silver in water. So see here, colloidal solution of silver in water. Silver in water. Now, silver in water, which is relatively less in quantity, which is relatively more in quantity, come on fast, which is relatively less in quantity, silver. So, silver is lesser in quantity, and which is more in quantity, water. So, water is larger in quantity, correct? Now, here what silver is called and water is called in terms of dispersed phase and dispersion medium. What is silver? Very good. So, silver is called a dispersed phase. What is called a dispersed phase, and water is called a dispersion medium. Okay, so that is about the colloidal solution. So, colloidal solution, any colloidal solution if you take, that consists of two components. One is generally relatively large in quantity, other one is relatively less in quantity. Which is relatively less in quantity, that's called phase. Which is relatively more in quantity, that's called the medium. Clear? Now here some examples are there. Chalo. These are the examples you can see here. Dispersed phase, dispersion medium, and the type of solution and example. This is also important, students. Yeah, dispersed phase means which is less in quantity. Okay, so this side all which are lesser in quantity, and dispersion medium, which is all larger in quantity. So they are larger means what? More in quantity. These are lesser means less in quantity. Okay, lesser, larger. I can write otherwise more in quantity. Okay, so now we can see these all are these examples you can see here: fog, clouds, mist, smoke, automobile exhaust, shaving cream, milk, face cream, milk of magnesia. Okay, mud. These all are examples for the colloidal solutions. These all are examples for what? Colloids. Okay, colloidal solutions. So now see here. Here, for example, here dispersion medium is gas. See, very important here. Dispersion medium means what? More quantity is gas. And the more quantity is gas or air, then such colloidal solutions are called aerosol. What they are called? Aerosol. Aerosol. Sol means solution or colloidal solution. Aero means what? Air or gas is medium, dispersion medium. So, aerosol, liquid in gas, liquid in gas. So, fog, how it is formed? Liquid in gas means what? Water in gas, air. Clouds also same, mist also same. So, these all are examples for them, okay, aerosol. Similarly, solid in gas, here also aerosol, smoke. So, when you ride a bike, okay, you get the exhaust from the vehicles, right? What is that exhaust smoke? What it consists of actually? So, these are the unignited carbon particles. What are they? Unignited carbon particles. Means what? Not only carbon, some other particles also will be present. So the particles are mixing with the air. Okay, so that makes the smoke. So particles are what? Solid. Air is what? Gas. So solid in gas, solid in lesser quantity, gas in more quantity. That makes the smoke or automobile exhaust. So here solid is a lesser medium, means phase, and gas is a dispersion medium. So here gas and dispersion medium, that's what it's called, aerosol. Right? Now then come to the gas in liquid. So gas in liquid means what? Gas is less, liquid is more. That's called foam. Shaving cream, you know, no? When you apply the shaving cream, so you'll get a lot of foam. So a lot of foam from where we are getting. So here the gas is coming. Okay. So the gas in liquid is foam, and liquid in liquid is emulsion. Okay, that's called emulsion. Emulsion means water. Milk means actually oil in water or water in oil. Oil in water or water in oil is called as a emulsion. Example, milk and face cream. Solid in liquid, that's called sol, and milk of magnesia. Milk of magnesia is what? Magnesium hydroxide. You know, when generally which is used for the antacid. Okay. And gas in solid, again foam here. Liquid in solid, cheese, butter. Solid in solid, and colored gemstones or a milky glass. So these all are examples of the colloids or colloidal solutions. So how these colloidal solutions are made up of? By using this dispersed phase and a dispersion medium. By combining these both, we'll be getting the colloidal solutions. Okay, so it's a very important to understand the colloidal solutions. So students, once go through this one for 2 minutes. Okay. Okay students, so with this we stop today. So today we completed the colloidal solutions. So today's topic till here we end, and see what are the topics we discussed. These are very easy and simple topics. These all are, but future coming topics are little difficult, where you need to solve the problems also, right? So to solve the problems, you need to understand the concepts, and that all concepts here we are explaining. So listen the concepts properly, try to understand them, read in your material, okay, and so that you become perfect. Okay, so till the next class, bye, take care.